Hi all, and I welcome you to my YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to take chapter Limits and Derivatives of first year PUC. So let us go ahead with this, and I am going to take this in two parts. I mean to say part 1 and part 2. Two videos will be uploaded. The first part, that is today, we are going to discuss limits, and as you know that limits concept is very helpful for next year continuity and then the rest chapter, and coming to this year also derivatives. When I talk again, the limit concept will be very useful. So because of this, I thought let it be into two parts. Each and every concept in detail we are going to discuss, along with we are going to solve all the three model question paper problems. Okay, so let us start with this, the chapter limits and derivatives. See, when I just observe all the three model papers which is issued in 2025, I mean to say, 2024 and 2025, we have got one marker question in MCQ, one fill in the blanks also, then two, all the whole, I can say that 5 plus 9, okay, 5 plus 4, 9, approximately 15 to 16 marks. So I would like to aim as 12 plus, okay, 12 plus marks. So with this, let us try to go ahead. Better we'll keep as 11 plus only, okay, to be more precise. So now let us first try to understand the reason why do we need limits, okay. So today we are going ahead with limits. So limit, why do we need? Having discussed relations and functions chapter number 2 of first year PUC, let's first recall what's a function. Function is a special type of relation where every element have one and only one image, right? Nothing but unique image. So here, if I take a function, for example, and whatever we are discussing, limit concept, derivative, all are on function. Nothing but we should have only one image. Now, if I take a problem, let us suppose f of x is equal to, this is your question number 1. If f of x is equal to x square minus 1, and I'm asking to evaluate this problem at function at 3. So how are we going to evaluate? See, coming to the solution of this, when I want f of 3, that's what's given in the question. See carefully, in place of x, what do we have? 3. So just we have to substitute that in place of x it is 3. So I will get 3 square minus 1. 3 square is 9 minus 1, and nothing but 9 minus 1 terms. The number signs are different. Here for 9 it is plus, and for 1 it is minus. So I have to subtract. 9 minus 1 is 8. 9 is a larger number, so sign is plus. So it is plus. So f of 3 is plus 8. This we call function value. Okay, functional value. Now try to understand this term. Whenever we are getting any value of the function, just by substituting like this, we call this as functional value or function value. Now, when we have got this thing of finding the function value for, so if I regard with respect to chapter relations and function, this is a function defined, and I want to find the image of 3, and we have got it to be 8, correct now? So now, when we have got this, why do we need limit concept? That will be one question. Now just see if I take one more problem. Let us suppose f of x is equal to x minus 1 divided by x with this sign, x minus 1 divided by minus x plus 1. Now, what is the value of f of 2? Let us suppose we want this value. I want the function value at x is equal to 2. Okay, so when I want to substitute here, x is equal to 2, in this equation, we are going to have function at 2 is 2 minus 1 divided by minus 2 plus 1, or I'll get 2 minus 1 is 1, minus 2 plus 1 is minus 1, so I'll get here minus 1, which is actually a real number. Always we want real number, here also it is a real number only. So here, if you just see, I got the function value at 2 as minus 1. Actually, if you observe carefully the given question, this function, as we know algebra function, so we have got division of two function and the denominator should not be equal to 0, nothing but this term. Let us copy again here. So see carefully, the denominator minus x plus 1 should not be equal to 0. Or solve for x, I can transpose this term here. So minus x should not be equal to minus 1, or negative will get cancelled on the other side. X should not be equal to 1. So the denominator to be defined, x should not be equal to 1. So it also means that we cannot find the function value at x is equal to 1. You can just see here, if you just see carefully, here x multiple is positive and here x multiple is negative. Correct? Now, if you take minus common, either in numerator or denominator, if I take minus common in numerator, so minus of, so see this, minus into plus is minus x, minus into minus is plus 1, divided by what we are going to have, minus x plus 1 as it is. Now here, be careful. Can I cancel this? Yes, I can cancel provided x is not equal to 1. Only then we can cancel. Without writing this condition and cancelling is a mistake. So first I am writing the condition and then I can cancel and I'll get minus 1. So mean to say f of x is equal to minus 1 provided x is not equal to 1. This condition should be specified. Now one question might come, sir, why it is so? Because usually, as soon as you see numerator same, denominator same, you're just cancelling. Don't forget, from our school days also, if at all you're cancelling any term, for example, see this carefully, 3 by 3, cancel, what will you get? 1. 0.001 divided by 0.001, both will get cancelled. 1. It is both non-zero terms. You just see, if I just take this again, the question back here, f of x is equal to x minus 1 divided by minus x plus 1. If I'm going to evaluate at 1, x is equal to 1, see what happens. I get 1 minus 1 divided by minus 1 plus 1, that will get 0 by 0 form. This, don't think of cancelling. Don't forget what is rational number. First of all, real number. For real number, denominator should never be equal to 0. So first, I should not have denominator to be 0, but in this case, both are the 0, and this we call indeterminate form. Indeterminate form. Okay, and there are so many problems like this where the function concept can't give us the value. Now, I mean to say, we can't get the image of 1. So that's the reason we have to go for a new concept, that is limits. And it also means that the problem whichever we have got here or here also, this problem also can be solved with the help of limits concept there. So whenever we are going to whenever we are not able to solve or get the value of a function just by substitution, then we are going to go for limit concept. That's what we call function value is not obtained. Now for this, at x is equal to 1, function value cannot be obtained. And here you should also understand that this particular expression whichever we have taken, it will, I repeat, this particular function will always give you minus 1 whenever x is not equal to 1. You can check whichever number you want other than x is equal to not equal to 1. Whenever x is not equal to 1, we will get always the function to be what? Minus 1. So having this logic, why do we need limit concept? Let us try to understand the concept of limits. First, I have given the reason here. Okay. So kindly just you can make a note of this. So dear students, having understood the reason behind the requirement of limits, now let us try to understand the concept behind this. So limits, let us try to understand graphically. This will be the best advantage for us to know the things graphically. because in graph, no, we understand actually what is happening. So see carefully. I'm taking the coordinate axis, and as usual we know the point of intersection of coordinate axis is origin, and they are mutually perpendicular, both the coordinate axis. Now let us suppose that I have got a graph, and whatever we are discussing is only for a function. So now y is equal to f of x is the given graph equation. Now let us suppose that at this particular point on x-axis I have got a point. Now see carefully the point A. In how many ways can we approach the point A? The point A, this point A can be approached with respect to x-axis either from the left or from the right. I can approach from the left or and right. There are two ways. This is the path to go to A. This is only the path. Okay. Now, when I am approaching left to A, see the corresponding value of y is here. Again, I am approaching here. Still, I am here. When I am approaching still left to A, see, I am coming nearer to A, and I am also coming to some value of y. So again here, then here. Again when I am here, again here. Again when I am very near to this, yes. Again still near, I am here. So I am approaching to a particular value. And this, let us suppose the value is L. So here, when I am approaching from the left of A, the point A can be any real number. Now, when I am saying A, is A positive or negative? I know majority of the students, as soon as they see A, they will say positive. Why? Sir, there is no sign here, so it is plus. Dear student, this answer is wrong. What is A? Real number. If they are positive, negative or zero, you will keep quiet. You are not going to comment anything. Reason. Let us first come to your basic knowledge. Sir, whenever sign is not mentioned, it's always positive. Try to understand whenever given particular number, for example, 6 I have taken. Now since 6 is a particular number, a known number, a given number, what's the sign here? Plus, because there is no sign mentioned. So 6 is positive. Whereas if I take minus 6, it is what? Negative. Okay, I hope this point is clear. So A, positive, negative, we are not going to comment anything on that. A is only a real number. So it means this A can be either on positive part of x-axis or negative part of x-axis, or it can be 0. So one thing is very clear, the point which we are discussing, the point A which we are discussing is lying on x-axis. Lying on x-axis. So if I talk with respect to chapter function, as you know, f is a function from where to where? A to B. What is A? Domain. What is B? Codomain. So it's very clear that always whenever I talk about any point, that point is lying on the domain. Okay. Now you see carefully, I am approaching the point A from the left of what? X-axis. I am moving to this, and this we call left hand limit. What we call? Left hand limit. And this, how are we going to write? This we are going to write in short LHL. So we call this as left hand limit. In short we write LHL, and it is given as limit of f of x as x tends to a minus. Try to understand the notation carefully here. I wrote here a minus. What's the meaning of this minus? Let us highlight. What is the meaning of this minus? Dear student, this minus is nowhere saying this A positive or negative or 0. No, it is only saying that with respect to A, I am coming left. I am approaching left of A. That's it. So this negative is nowhere talking about the positive or negative of A, nor even 0 also. Similarly, see carefully, with respect to A, we can approach right to A. I am here. When I am here, the corresponding y value will be here. Again, when I am here, again. when I'm approaching still here, my corresponding value is here. Again here, it is here. Again I'm coming here, it is still near. Again I'm coming here, it is still more near. And again it's moving to the value. It's approaching to the value. It's moving to the value L. So as and how I am moving towards A, the corresponding y value is moving to the function value is moving to L. So this we take this part we call right hand limit. In short, we write RHL, and it is limit of f of x as x tends to a plus. Okay, again this plus which is there here, this plus is nowhere specifying whether a is positive, negative or 0. This plus is only specifying that with respect to the point A, I am approaching from right of A. Okay. Now, when do we say limit exists? See carefully from the graph. First of all, for a function, we should have only one image. And for this function, the image is L. And let it be left hand limit and right hand limit, both are approaching to one number L. So, when do we say limit exists? We say limit exists if left hand limit exists. This should exist. Whatever the value I'm getting, it should exist. Let's suppose this value is what? L. No. L belongs to a real number. So when I say belongs to a real number, it means it exists. Similarly, this is also the L. Correct? Now here I took L because here it is approaching to L. And this is also what? L and belongs to what? R. When I say R, don't forget both plus or minus infinity does not belong to R. R is in fact open interval minus infinity to plus infinity. So both left hand limit should exist as well as right hand limit should also what? Exist. And not only that, both should be equal. That's what you can see, both are approaching to same value L. So limit of f of x as x tends to a minus left hand limit should be equal to limit of f of x as x tends to a plus. And in short, sometimes interpreting like this, we can just write LHL is equal to RHL. Okay, and whenever this happens, we only write limit of f of x as x tends to a exist. Whenever we say limit exists, it should be understood that left hand limit exists, right hand limit exists. Not only that, even the value is also what? Same. Now let's try to understand why is that left hand limit exists, right hand limit exists, understood. But why it is that the value should be equal. Let us try to understand. This is our first graph. Let us understand graphically. See carefully here. Second graph. If I have a function here, again a function graph, always we are bothered about function. And let us suppose that my graph is going to be this. Now, my point at which I want to discuss the limit value is again the point A here on x-axis. So one thing before I go ahead, let it be very clear. When we talk about a point at which we want to check the limit value, it is always there in the domain. Whereas you see my limit value is always on y-axis. So limit value as well as function value both come from a codomain. So let's have a thing here, limit value and function value okay belongs to what? Codomain. Both this will belong to what? Codomain always. Okay. Now having this information, now let us come here. Let us suppose that this value, particular value, whatever I'm going to get is L1, and this particular value, whatever we get, it is L2. Okay. Now I want to find the limit at limit at x is equal to a for the function y equal to f of x. In how many ways can we approach a? There are two ways. One from the left, other from the right. So when I want to approach from the left, see carefully. When I am left of here, see, when I'm here, corresponding value is here. Again 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 when I'm here, corresponding value is here. So you can see left hand limit, nothing but limit of f of x as x tends to a minus, we have got L2, which is a real number. Similarly, when I talk about right hand limit, limit of f of x as x tends to a plus. See carefully, a plus I said, nothing but right of a. So when I'm here, corresponding element is here. When I'm again here, corresponding element here. When again here, corresponding element here. When again here, corresponding element here. Again when I'm here, corresponding element. So it is approaching to this number. This number, what is that? Here, L1. Now from the diagram, see carefully. Before that, left hand limit is L2, right hand limit is L1. Now if you see very carefully, L2 and L1 both are not same. You can see there is a gap in between them. It means what? These two are two different real numbers. So one thing is very clear, that L2 is not equal to L1. And it also means that left hand limit is not equal to right hand limit. Not only that, what is left hand limit? It is this limit of f of x as x tends to a minus is not equal to limit of f of x as x tends to a plus. So whenever left hand limit is not equal to right hand limit, even though left hand limit exists, right hand limit exists, but they are unequal. See what is happening when they are unequal. They are having two different values, which is against the definition of a function. What is a function? Every element should have unique image. So even the limit value should be also what? 1. But here I've got two different limit value. And one more thing, to be very particular, let us try to give a close ball here. Don't forget, in the interval concept, in the intervals concept of chapter set, we have discussed that close ball means value taken, open ball means value not taken. So here if you see, close ball is taken nothing but even the function value. I just want to understand this close, whatever I've given, no, it's a function value. So this, let us again right here, this is what? Function value. Okay, value obtained by the function without even using the limit concept. Nothing but at x is equal to a, function at x is equal to a, if I substitute x is equal to a here, my function at a, y is equal to f of a, value is what? L2. This we call function value. So here, as I said, if left hand limit, right hand limit exists but they are unequal, it is not going to obey the definition of function. Okay, that's the reason there. So if at all limit value exists and they are equal, only then we say limit exists. In this scenario, we say that limit of f of x as x tends to a does not exist. Does not exist. Whereas here you see, here left hand limit exists, right hand limit exists, both are equal to L. So the other way of, and here this value exists and this value is what? L. We got the value to be what? L, and then we are saying it is existing. Let's write it here with more space. L is a real number and this value exists. Now here try to understand this. Actually what is happening here? As and how I am approaching to what? A, my f of x is approaching to L. You can see now f of x approaching to L. So I can just say the meaning of this is as x is moving to A, f of x is approaching to L. Again I repeat, as and how I am approaching, as and how x is approaching to A, f of x is also approaching to L. So in place of writing like this, we just write limit of f of x as x tends to a is equal to L. L is a real number. If it is a real number, only then we say it is existing. Except chapter complex number in first year PUC, remaining all are real valued function. When I say real valued function, both domain and codomain should be set of real numbers or subset of real numbers. Okay. Under chapter 6, number system, we have discussed any subset of whole number subset of integer subset of rational number, and rational number subset of real number. Similarly, irrational is subset of, I repeat, irrational is a subset of real number. On the whole, real number is union of rational as well as irrational. All this we have discussed there. Okay, so fine. So this is what, no, whenever we say about limit exists, left hand limit exists, right hand limit exists, and both should be equal. If it is equal, means if the value exists but they are unequal, then it is the limit does not exist. Okay, now one question might come, sir, here both left hand limit, right hand limit were real number. What if it is not a real number? Let us have a scenario of that also. First, make a note of this. Okay, dear students, let us take one more graph where we can think about what if one of the limit doesn't exist, and then we can go ahead with the one problem from model question paper. See carefully. I've got one function like this graph. It's moving up, 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 and I have got one point here, and here what's happening with this particular graph is the graph is just moving on, moving on, moving on. It's never touching this vertical line. And there is one more graph like this, and it's having this value. Let us suppose that this value is L1. Now I want to find the limit value of this y equal to f of x. See how many ways can we approach the point A. As usual, since this point A is lying on x-axis, I can either approach from the left or from the right. This is called neighborhood. Okay, neighborhood. So when I approach from the left of A, the corresponding, for this I am here. Again for this I am here. Again for this point I am here. Again from this point I am here. Again for this point, yes, I am here. Again very near, I am here. This graph is not stopping. It's just going to move, 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 move. So, and when I'm saying it's going to move to other high values, don't forget y is going to increase the value. If it is 1 here, then 2, 3, 3.5, 3.7 moves up, up, up. It's a very, very huge quantity. So I can say that left hand limit of f of x as x tends to a minus is equal to infinity, which is not a real number, because R is always open interval plus or minus infinity. Don't forget, plus or minus infinity is not a real number. It's just a notation. Plus infinity along x-axis, very huge quantity. As now we move towards the right of origin. And again, when we move left of origin, we get a very least quantity, a negative value minus infinity. Means we just approach to a very least quantity, and that we just give a notation as minus infinity. Similarly, below y-axis, negative, least value minus infinity, and as and how we go above, we get a very huge value. So this notation as plus infinity. These two are not a real number. That's the reason you can see I'm not marking the way I have marked point A on x-axis as well as L1. Now coming to the right hand limit, if you see limit of f of x as x tends to a plus. When I say a plus, I'm coming from right of a. So see carefully, when I am here, corresponding element is here, number is here. Again when I'm here, I'm approaching here. Again when I'm here, again still here. Again come near to a, again here. Again come near. Again I'm here. Again when I come here, yes, I'm approaching this value. It is L1. And it's a real number. But left hand limit does not exist. Right hand limit exists. So left hand limit what? Does not exist. Whenever we get infinity or minus infinity, it is what? Does not exist. Right hand limit exists. But whenever this happens, limit does not exist. So whenever any one of the limit, first if limit exists, they should be equal also. If they are unequal, limit does not exist. Even if one of the limit exists, here in this case right hand limit exists, but left hand limit does not exist, again it is same, no, it's not approaching the same value. Okay, it's not going to obey the function definition. So I can say limit of f of x as x tends to a does not exist. Okay, the same scenario can also happen that right hand limit does not exist, nothing but I can have some plus infinity, and left hand limit exists. Again, the thing will be what? Limit does not exist. Can also happen that both are tending to infinity or minus infinity. Again, in this scenario also, limit does not exist. Ultimately, for a function to have limit, left hand limit exists, right hand limit exists. I repeat, left hand limit exists, right hand limit exists, and both should be what? Equal. So I hope the logic is very clear. We are going to start up with the problem. Make a note. Dear students, having understood the basics of the limit, let us move on to model question paper number 1 issued by PU board, and for the academic year 2024 to 2025. And this question just goes with the concept, a very basic concept of limit. Question says 1 marker question. Okay, as we know, first 15 questions are 1 marker. Fill in match the following. I mean to say, I'm sorry. First 15 questions are MCQ based. Okay. For the figure given below, this is the figure below. Consider the following statement 1 and 2. Statement number 1 says the given function limit exists at x equal to 1, x equal to 2, and x equal to 4. Statement 2 is the given function limit exists at x equal to 3. So as you can see here, I have got a graph whose equation is y equal to f of x. They are talking about, first let us focus on x, statement number 1. I have to check whether the limit exists at 1, 2, 4 as well as 3. Okay, let's go for all the 3. Coming to 1, see carefully. When I am left of 1, I'm approaching this value. Again, left of 1, approaching this. I am approaching to 1. So one thing is very clear. If I talk about at 1, okay, let's take the solution here. If I'm talking about at x is equal to 1, the left hand limit, that is limit of f of x as x tends to 1 minus left of 1, so 1 minus, you can see I'm approaching to 1 only. Okay, as I'm approaching to 1 on x axis, I'm approaching to 1 on y axis. Similarly, when I'm approaching from the right of 1, you can see I'm here, again near to 1, again here, again very near to 1, again here, and there is again going to which number? 1 itself. So even it is also equal to the right hand limit. So in this case, left hand limit and right hand limit both are same. This is right hand limit. So limit exists. So therefore I can say that limit of f of x as x tends to 1 is actually 1 and it exists. First part done. Now let us move on to the point 2. Okay, this is existing. Now I want to talk about x is equal to 2. When I'm talking about x is equal to 2, as and how I am approaching left of 2. Yeah, here I am. Corresponding element is the limit value is here. Again, as I'm approaching, I'm coming here. Again, approaching, coming here. See, as I'm approaching 2 from the left of 2, I'm approaching to a very value, a near value to 2 itself. So left hand limit, limit of f of x as x tends to 2 minus the left hand limit is approaching 2. As I'm approaching left of 2, you can see I'm approaching to 2 on the y axis. So my left hand limit is 2. Let us move on to right hand limit, limit of f of x as x tends to 2 plus. See, I am right of 2 here. Then the corresponding y values here. Again right hand, right to 2, near to 2, again here, again near to 2 here. As and how I am approaching right to 2, I am approaching to this value. And what is that value? 3. So the right hand limit is 3. Recall the concept of limit to exist. Left hand limit should exist. Yeah, it is there. It's a real number. right hand limit also exists. It's a real number, but 2 and 3 are not equal. So since 2 is not equal to 3, I can just say that left hand limit is not equal to right hand limit. This implies limit of f of x as x tends to 2 does not exist. Does not exist. So at x equal to 1, yes, exists, but x equal to 2 does not exist. But the question said, the option said, statement 1 said the function exists at x equal to 2 also. So very clearly, statement 1 is false. Let's understand the concept still more better. Very beautiful question has been framed. Let's check the remaining also. But already we came to know statement 1 is false. Okay. But we have to also go for statement number 2. Let us see that. See carefully. 3. In how many ways can we approach 3? See this carefully. Left of 3. When I'm here, corresponding element is here. When I'm here, again corresponding element is here. Again when I'm here, corresponding element is here. And that is again approaching to which number? 1 on y-axis. So at x equal to 3, I can say that left hand limit of f of x as x tends to 3 minus, when approaching left of 3, I am moving to 1. Similarly, even when I am approaching right of 3 here, again I am approaching to what? 1. So it is also equal to right hand limit. So very clearly, we can say that limit of f of x as x tends to 3 is equal to 1 and it exists, belongs to R. Similarly here, yeah, same thing happened. Now 4, come to 4. Coming to 4, as I now approaching left of 4, I am approaching this number. What is that number? What is that number? It is approaching to 2. Okay, it's approaching to 2. So at x equal to 4, left hand limit of f of x as x tends to 4 minus left of 4, it's approaching to what? 2. Similarly, right hand limit is also approaching to which number? 2 only. You can see as I now go from here, yeah, it is approaching to this, which is that 2. So this implies limit of f of x as x tends to 4 is equal to 2, and yes, it exists. Okay, so statement number, this is also exists, this also exists. Statement number 1 is false because at 2 limit does not exist. So statement number 1 is false as x equal to 2, at x equal to 2 limit does not exist. So option B is correct. Very good example they said. Okay, and I work for you all this, but as soon you see the graph, oh okay, see this much of work not required. It's only for explanation sake I wrote. As soon you see 1, I'm coming from the left also, right also, both are approaching to same number. Therefore, at 1 limit exists. Come to 2. When I come from left, it is approaching to 2. Right of 2, it's approaching to 3. Limit does not exist. Over. Come to 3. I'm approaching left of what? 3. When I'm approaching to which number? 1. Right of 3, when I'm approaching, it's approaching to which number? 1. Limit exists at 3. At 4, yes, left or right, whenever I approach from left or right, is approaching to a number 2. Therefore, limit exists. So very easily we can say, but I just wrote the working. Let you also know the presentation as well. Okay. So limit exists here, exists, and there it does not exist. Okay. Kindly make a note of this. Yeah. Dear students, before taking up the problems which is there on the board, let us try to understand one more concept. See, whatever the graph I've taken, we had only one function, that is y equal to f of x. Let us suppose we have got more than one function. Then how are we going to compute the limit of those? So on that we have got algebra of limits. Let us have that one here. Now what this algebra of limits says? Algebra of limits. See, same like school days, no? After learning the numbers, algebra of numbers, we have to learn nothing but how to add, subtract, multiply, divide. Same thing here. Let us suppose that, yeah, I have two functions. Let us suppose that I have got two functions. If limit of f of x as x tends to a exist, and limit of g of x as x tends to a exists. For first primary condition is that the limit which we are into consideration both should exist. Then first, even the sum, when I want to find, as well as difference, okay, let us club together. We can write this one as individual limit, provided both the limit exist. Only then we can split like this, and both are tending to same point. Be careful. Second, let us suppose I have got product of two functions, f of x, then g of x. I want to evaluate this limit. I have product of two functions. This is same as limit f of x into limit g of x as x is tending to a. So here both are product of two variable function, f of x and g of x. It may also happen that I may have a product of a constant and a variable function g of x. So a constant function k and variable function. See, I am using the word variable function because f and g have got no term x here, I think, but it's going to vary as a now x will also vary. But here for k there is no x k of x type the way it is given here. It is not given. I think but k is a scalar. It's not going to play any role in the contribution of limit. So k can be taken out, the constant, and then apply the limit on the variable function. This is actually a special case of this. Okay. So if I just take k to be f, so it's k here. Wherever x is there, replaced by a. I think but x is tending to a. But since x is not there with k, this term don't have x, k remains k only. Okay. Next, limit f of x divided by g of x as x tends to a, the division part. So it is same as limit of f of x as x tends to a divided by limit of g of x as x tends to a. As x tends to a. And this limit exists. This limit exists under what condition? Provided what? Limit of g of x as x tends to a should not be equal to 0. If it is not equal to 0, only then the denominator should not be equal to 0 after applying the limit. Only then this limit will exist. In short, what we are saying, if f and g are two functions where the limit exists, then coming to sum, difference, or product, or scalar multiple, or division, we can evaluate individually, nothing else, provided the limit exists. Okay, we can split them. In place of applying on this, we can split them and apply. Now let us come to model question paper number 2, a 1 marker question. It says evaluate this. See, coming to limit, this first method is method of substitution, direct substitution, nothing but wherever x is there, replace by whatever the limit is given, and check are you getting a real number or you are getting indeterminate from 0 by 0. Okay, so I thought I will take this problem simultaneously. I'm also explaining that method. So method is here direct substitution. So when I go for, let's just give the method name here. Method number 1. Method of direct substitution. Direct, oh sorry, spelling wrong. Direct substitution. Now this is, question says evaluate the limit x cube minus x square plus 1 as x tends to minus 1 is, these are the options. So coming to the solution of this, see carefully the solution. So coming to the solution, wherever x is there, replace by minus 1. So let us first write the question, limit of x cube minus x square plus 1 as x is tending to minus 1. So here very clearly, wherever x is there, replace by minus 1. So here we have got minus 1 the whole cube, then minus, again place of x minus 1. So minus 1 the whole square plus 1. Minus 1 the whole cube is minus 1, then minus of minus 1 whole square is 1, then plus 1. Be careful, square is only for this minus, not for this. Okay, so this minus as it is, minus 1 the whole square is 1. So we are going to, you can see minus 1 plus 1 will get cancelled, minus 1 is remaining. So minus 1 is there in option A. So option A is correct for the first problem. Coming to the 13th question, and this is a model question paper 3. And this question, again a 1 marker. Consider the function f of x, where f of x, this is not first time we are seeing a flower bracket. In the chapter of functions I have discussed there, flower bracket will come into existence whenever the function is behaving more than one manner. So the function is going to take the value 2 whenever x is positive. Function will take the value 1 whenever x is less than or equal to 0. Then we have to find the left hand limit of f of x at x is equal to 0. So they have specified the point at which point we have to find the limit. So solution, limit, since I want left hand limit, okay, since I want left hand limit, so limit of f of x as x tends to 0 minus, let's plot on the number line, 0 is here. So this is left of 0, nothing but less than 0. When it is less than 0, f of x is 1. For x is less than 0, f of x is 1. So for all this x less than 0, f of x is 1. Similarly, when we see x is, and actually even at x equal to 0 also, it is taking f of x to be 1. The function value is taken as 1. When x is more than 0, strictly more than 0, for entire this, my f of x function value is 2. F of x, the function value is 2. Now we have to evaluate left hand limit, 0 minus 1. When I say left hand limit, I am coming left of 0, left of 0, left of 0. Left of 0 is what? Less than 0. So limit x tends to 0, left of 0 nothing but less than 0, f of x is 1. See carefully, as soon I chose the function in place of f of x, which function it is, I didn't put minus because I have chosen the function. Here minus is written because I have yet to choose the function. So wherever x is there, replace by 0, method of substitution. Do we have x here? See carefully, for this problem when I replace x by minus 1, since I had x here, I change as minus 1. Again, since x is there, minus 1. But here x was not there, so 1 remained 1. Similarly, here x is tending to 0. Do we have x here? No. So 1 will remain 1. So my left hand limit value is what? 1. 1 is there in option A. So option A is correct. I'd like to see you to comment what could be the right hand limit of this question. This is your assignment. Okay, I want to see how many will comment right hand limit. Okay, make a note of this. Dear students, having completed 1 marker question from all the 3 model question papers, now let us try to move on with some other concept before taking up the model question paper problems. I have given here indeterminate form, 0 by 0. Actually, we have 5 or 6 more, but coming to PUC first year, we have only 0 by 0 form. And when I was discussing the concept, I just rose this point, why do we need limit? And I also said that whatever we can get by evaluation of function value, even limits can be used to get those values there. But the major reason for limit to be considered is having the indeterminate form, 0 by 0 form, coming to first PUC, how to evaluate. Now, Before you evaluate, you should know whether it is for 0 by 0 form or not. Now, previous two questions we have taken, no, we didn't got 0 by 0 form. One question we got -1 as answer, other I think 1 or 2 we got as the answer. So first, your primary thing is apply method of substitution. Method number 1. You apply that. If you get 0 by 0 form, then the next method should be applied. Now see carefully, where this says limit of 3x square minus x minus 10 whole divided by x square minus 4 as x is tending to 2, evaluate it. Now if I evaluate this says wherever x is there, it is tending to 2. So direct substitution. So 3 times of 2 square minus 2 minus 10 whole divided by 2 square minus 4. 2 square is 4. 4 3s are 12 minus 12 because minus 2 minus 10 is minus 12. 2 square is 4 minus 4. So we are getting 0 by 0 form, which is indeterminate form. Now what is the procedure? Procedure for this is method of factorization. Now whenever you get 0 by 0 form, and if you have a polynomial, or you can say that you have got some quadratic or polynomial terms, try to factorize them. So method of factorization. See, these words are not there in the text, but they have implemented without the name. Okay. So limit of factorize this. It's a quadratic equation. Let us try to factorize 3x square in the working column. Let us factorize minus x minus 10. 3 tens are 30. So factorize 3 tens are 30. Then 2 5s are 2 3s are 6. 6 and 5. Yeah. Minus 6 plus 5 will be minus 1. So I can just have this 3x square. Then what's that? Minus 6x plus 5x minus 10. So here the common is 3x. So I'll get x here, correct? Out of 3x square, 3x is common, so 1x is remaining. Plus into minus is minus. 3 2s are 6, x is out. Then here common is plus 5. Then x, correct? Now 5 is common, 5 by 5 get cancelled. 5, see, minus 10 by 5 will be minus 2. So always in method of factorization, we know that the factors should be common. Yeah, it is common, only then our factors are right. And then 3x plus 5. Here, when I'm saying our factors are correct, I mean to say the given quadratic we are able to factorize. Don't forget, every quadratic equation need not be factorized. Thus we have a formula x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this is a formula to evaluate. Now anyway, coming to numerator, we got it to be x minus 2 times of 3x plus 5. Coming to denominator, we have x square minus 4. I can factorize this. X square, 4 is same as 2 square. Now I can use the formula. A square minus b square is same as a plus b into a minus b. So this will be x plus 2 times of x minus 2. In place of a, x, in place of b, 2. So now let us substitute. Coming to denominator, we have x plus 2 into x minus 2 as x is tending to 2. Now see carefully, we have a common factor both in numerator and denominator, that is x minus 2 and x minus 2. We can cancel them. Now I know many students will say, sir, how can you cancel? Sir, this is as x is tending to 2, 2 minus 2, 0, 2 minus 2, 0. You are cancelling 0 by 0. No, my dear students. Actually, what's happening? Understand. We are tending to 2. So this is something like when I'm tending from left of 2, I am very close to 2 from left. It can be 1.9. 1.9. So you see this. X is 1.9. 1.9 minus 2. Here also 1.9 minus 2 will be minus 0.1. So minus 0.1 has got cancelled. Still more near number. X is tending to this one, no. 2, no, from the left. In place of 1.9, it can be 1.000009. Still more closer. Oh, then I can say this one, no. 1.9999999 if I just move on and on. If I subtract with -2, what is going to happen? 0.000 somewhere 1. Divide by same thing. I am dividing by non-zero same term. Similarly, when I come from the right also, 2.000 somewhere 1. If I got 2.000 somewhere 1 from the right of 2, subtracting with -2, what's going to happen here? 0.00000 somewhere 1. And anyway, here it is minus. Okay. 1.999 minus 2 is minus 0.000 somewhere 1. And here 0.00 somewhere 1. Again, both the terms are going to get cancelled. So I hope the logic is clear. This we are not going to show in exam also. It's understood. So I just give the clarity for you. And one more thing you should understand. Benefit of method of factorization. See, before applying, as you saw, this is the term which is giving 0. This is the term which is giving 0. So method of factorization is cancelling that factor which will give 0 by 0 form. Method of factorization is cancelling those factors which is giving what? 0 by 0 form. So now let us write down the remaining limit 3x plus 5 divided by x plus 2 as x is tending to 2. Wherever x is there, replace by 2. So what we will get? 3 times of 2 plus 5 divided by 2 plus 2. 3 2s are 6 plus 5 divided by, let us write properly, 6 plus 5. 2 plus 2 is 4. So we are getting 11 divided by 4. Yeah, it's a real number. Okay, I hope the things are clear. Now let us move on to this question. First, always you have to think of applying what? Method of substitution. If you are getting 0 by 0 form, only then method of factorization. Should not happen, no? Like our two previous problem, you just went for method of what? Factorization without applying method of direct substitution. Always method that is direct substitution will be applied by you. Only that method will suggest you, are you getting a directly real number or 0 by 0 form. See this question. Wherever x, the question says evaluate this limit 1 by x plus half divided by x plus 2 as x is tending to -2. Okay. So if I apply this, see carefully. Wherever x is there, it should be -2. So 1 divided by -2 plus 1 by 2 divided by -2 plus 2. This will get cancelled. I'll get 0 by 0 form. Oh, I got indeterminate form. Now let us go for the solution. Only after knowing that is indeterminate form, we are going to apply method of factorization. See carefully. Can you see a fraction here? So can't I take the LCM? LCM of x and 2 will be 2x. Then 2x by x. See carefully. 2x by x. X by x will get cancelled, get 2. So this 2 into numerator. 2 into 1, 2. Again 2x divided by this 2. So I'll get x. This x is multiplied to numerator. 1 into x is x. And this term as it is. Many students while writing, they will think to write this one as divided by x plus 2. No, my dear students. See the location here. This is the denominator. So I should go to denominator only. Okay. Now see again carefully. X plus 2 and 2 plus x both are same term. I can apply the same logic what I just gave it here, and this 2 term will get cancelled. And again when you are cancelling, just see, if you substitute x as -2, 2 minus 2 0, 2 minus 2 0, means -2 plus 2 here 0. Nothing but both are tending to 0. Nothing but 0 by 0 form is again the factor which is giving 0 by 0 form is being cancelled by this method. So what is remaining? Limit 1 divided by 2x as x is tending to minus 2. So 1 by 2 times of minus 2. Minus 2 into 2 is minus 4. Nothing but minus 1 by 4 belongs to R. This is the limit value. This we call limit value. Whenever we are going to find or evaluate the given function by using the concept of limit, we say limit value. Okay, I hope the things are clear. Now here one point, first make a note. Now here one point is, now we factorize this and this because it's a quadratic, we are able to factorize. But if it is higher degree like 15, 16, we cannot factorize. Max to max we can factorize quadratic, cubic also to some extent, and even biquadratic means degree is 4, but they are given in some pattern, then we can factorize. But what about if it is higher power, even for cubic also? No, do we have a particular method? Yes, we have. Let us derive that result, and that has come in the model question paper. So I will simultaneously do both the things. Okay, make a note. Okay, dear students, having completed indeterminate form, okay, for a quadratic, linear, okay, expressions, as I said that if the power is higher, as you can see, here, power 15 and power 10, then you cannot think of method of factorization. So for that we have got this derivation. This derivation usually comes for 3 marks, but in model question paper number 1, it has come for 5 marks, and there is one error. Here it is mentioned 0, it is not 0, it is A. Okay, so 5 marker question. And we have a sub problem. The question says, and in NCERT text, this is theorem number 2. As a theorem they have given, it is theorem number 2 in NCERT text. Question says, prove that for any positive integer n. So here, whatever n is present here, it is positive integer. Limit x power n minus a power n whole divided by x minus a as x is tending to a is n into a power n minus 1, and then we have to evaluate this. First, let us try to get the proof of this. Since it's a theorem, I would like to say as proof than saying solution. Okay. Now you see carefully. First, let us take the given question. And one most important thing which is not quoted in the theorem, that I quote that. What about A? N we said positive. Coming to A is also positive. Let us be very clear. A is a positive real number. Okay. Now x is tending to A. First, as I said in the previous problem, first apply method of substitution. Directly don't think of applying indeterminate concept. You are going to apply provided you are getting 0 by 0 form. First check that. If I apply the limit, wherever x is there, I have 2. I am moving towards A. So wherever x is there, replace by A. So when I do so, you see here, this will become x is replaced by A, nothing but x is moving towards A. So I'll get a power n minus a power n divided by a minus a. And here both will get cancelled. A power n minus a power n divided by minus a will get cancelled. I'll get 0 by 0 form. Nothing but this is indeterminate form. Now, we cannot apply method of factorization. We can apply provided we can factorize. But here n is any positive integer. So we are discussing a general way. Now, observe carefully here. Is it now this expression inside the limit says x power n minus a power n is divided by x minus a. So I have to divide. But we can divide provided the denominator is non-zero term. Many will have it out. Sir, denominator is 0. No, my dear student. This 0 indicates we are approaching towards 0. We are approaching towards 0. We are not at 0. We are approaching to 0 as x is tending to a here. So surely both are what? Non-zero terms. So as x is not equal to a, I can think of what? Dividing. Now coming to division, you are nowhere expected to show that whatever the division method you used to do in school days. So just listen carefully, and the same thing you can write what I am going to explain. See, just if I divide x power n by x, what will be the quotient? Just see here x power n. Let us write it bit more right, because I will be having bit more lengthy expression here. X power n divided by x by using law of exponent. What it says? What is a power m divided by a power n? A power m minus n. So I can take this base to the numerator. Power sign will change. It is plus n will change to minus n. Similarly here, power is 1 here. So this will become x power n minus 1. So I am going to have this as x power. It means if I divide, the first term will be x power n minus 1. The next term will be, the power of x will decrease. It will be x power n minus 2 into a. Again, the next term will be x power n minus, see here it is minus 1, then minus 2. Next will be n minus 3. And see power of a. There is no power for a, there is no term a itself. So power of a is 0 here. Then a power 1. Here it is a power 2. Like this. What is my last term? Very simple. Divide this 2. Again, if you divide a power n by a, what will be a power n by a? With the same logic, we will get a power n minus 1. So my last term will be a power n minus 1. So in exam also, there is no need to show the division procedure. So when I'm dividing this, I'm getting this. And this is saying as, this is as extends to a. Now before I apply the limit, first count how many terms are there. Sir, how to count? We have got a general term. Yes, we can count even though it is general term. C power of a. If I start from here, why from here? Because a is present from here. It is not there in the first term. If I just see power of a is 1 here. Here it is 2 here. Till here I have got in each of this term from here to here. I have got what? A term. And we can just take power of a to be count of number of term. Here it is 1. Here power is 2. Nothing but second term. This is the first term. Until here n minus 1 terms. How many terms we have got? N minus 1 terms. And then I have one more term here. So n minus 1 plus one more term. Totally how many terms? N terms. I repeat, n terms. I repeat, these are n minus 1 plus one more. So I'll have n terms. So total number of terms are n. Now it is applied the limit. Wherever x is there, we are approaching to a. So wherever x is there, replace by a. So when I do so, wherever x is there, replace by a. So this will be a power n minus 1 plus a power n minus 2 into a plus a power n minus 2 into a. Come to this, a power n minus 3 into a square. So plus a power n minus 3 into a square. Like this, plus dot dot dot. And there is enough, 3 dots sufficient. Don't give too many. Okay. Then here, this is saying x is tending to a. We don't have x. So a power n minus 1 will remain same. Now again, by using law of exponents, recall what is a power m into a power n. It is a power m plus n. Is it not? So whenever bases are same, we can add the power. So this is only one term. I will write as it is. And see carefully. Here bases are same. So I can add the power. Here I have got power to be 1. So what is minus 2 plus 1? A as it is, n. What is minus 2 plus 1? Let's write step by step. No problem. Then here a power n minus, minus 3 plus 2. Okay, add together. Like this, my last term is a power n minus 1. So whenever bases are same, we have added the power. Now see carefully, first term no change. Coming to second term, here we have minus 2 plus 1. How much is minus 2 plus 1? Minus 1 only. Then plus a power n. Minus 3 plus 2 is minus 1. Like this, my last term is a power n minus 1. So I have got a power n minus 1 in each of the term. Don't forget, we already know before applying the limit, total number of terms are n terms. And when I apply the limit, none of the terms got cancelled. It remained the same. So here we have how many terms totally? N terms. Now recall one basic logic. Answer me. What is a plus a plus a? What's the answer? 3a, no? Similarly, what is a plus a plus a plus a? What's the answer? When you add 4a. Understand the logic here. Why it is 3a? Because this a are repeated 3 times. And this a repeat how many times? 4 times. 4 times. So from here one thing is very clear. If all the terms having same sign and each of the terms are same, just see how many times it is means given or added, how many times it is repeated, that multiple you can give and the same term. Correct now? So see here, how many times this term is added? N times. So why n times? Because n terms are there. So n times of which term? A power n minus 1. That's it. That's what they asked. And let us write the limit. The question. It can also come for 3 mark, my dear student. For 3 mark, they will not be asking the sub problem. So we have got the result, and in the question they have said n is what? Positive integer, nothing but it is a natural number. Before I take up this problem, let us take one small problem to understand how to apply this. Okay, one small easy problem we'll take. Let us suppose the question is limit of x power 5 minus 32 divided by x minus 2 as x is tending to 2. One thing you should understand, always x is not going to tend to 0. Majority of the problem, no, tending to 0 we are going to have later on. It doesn't mean that x should always tend to 0 only. It can be non-zero number also. It depends on the question. Okay. So now if I apply, first see, I'm not applying the formula. No, first think of applying method of substitution, direct substitution. Wherever x is there, replace by 2. So what I will get? 2 power 5 minus 32 divided by 2 minus 2. 2 power 5 how much? 32 minus 32 divided by 2 minus 2 is 0. 32 minus 32 will get cancelled. I will get 0 by 0, which is indeterminate form. Indeterminate form. Only then I am going to think of alternate method. Until unless you won't get 0 by 0 form. First method which we learnt just before was method of factorization. Now we have learnt this formula method. Why? Now I cannot factorize this. It's better to apply this formula. Now just see, to apply the formula, see carefully. Whatever term is there, same term in denominator. Whatever term is there in denominator, same term in numerator. A. But here what do we have? 2, but here 32. X and X matching. So I have to make numerator this 32 as in terms of 2 power. So see carefully. Limit of x power 5. Can't we write 32 as 2 power 5? How is that? What is 2 power 5? 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. And as soon I wrote in this form, see carefully, this term and this term are the same. See, xx, yeah, xx. Yeah, yeah. Whatever power is the same power. So now I have to just apply this formula. In the right hand side we have n and a. So wherever, if I compare with the formula equation number 1, wherever we have what? A. In place of we have a 2. So a is equal to 2. and in place of n we have 5. So n is equal to 5. Substitute here to get the answer. So what's the answer? N is what? 5. What is a? 2 whole power n minus 1, nothing but 5 minus 1. How much is 5 minus 1? 4. So I will get the answer to be 5 into, what is 2 power 4? 2 2s are 4. 4 4s are 16. What is 5 into 16? Final comment here. What is 5 into 16? 5 6 are 30. 5 1s are 5, 6, 7, 8, 80. And which is a real number. Which is a real number. This is our answer. I hope the things are clear. We are ready to solve this problem, but I thought before taking this problem, it's better to have one primary basic problem. Kindly make a note of this. Yeah, dear students, having completed the derivation, now let us take the problem. I hope this is very clear. So now see carefully. So coming to the sub problem of the question. This question is also asked as a 2-marker question, which I will just say after I complete this. Now, first what you will do, apply method of direct substitution. First see, are you getting 0 by 0 form or not? Wherever x is there, x is tending to 1. So x should tend to 1. So wherever x is there, replace by 1. So what will get? 1 power 15 minus 1 divided by 1 power 10 minus 1. 1 power 15 is 1 minus 1 divided by 1 power 10 is 1 minus 1. Answer is 0 by 0, which is what? Indeterminate form. Indeterminate form. Now, see carefully the formula. That's what, just memorizing right hand side is not important. What I mean to say is, for this is a standard result which you have to memorize. Apart from the derivation, you should memorize this result. Now, when you're memorizing, students have a problem that always they are going to memorize right hand side but not left. No. If I ask you what is the formula for a square plus 2ab plus b square, you should be able to say it is a plus b whole square. Similarly, what is a plus b whole square formula? A square plus 2ab plus b square. Both the ways you should be able to say. Similarly, whichever formula you learn, both the ways you should know. So now, first you see the left hand side. Power of x and a, both are n. It should be same. See denominator. Again, whatever is in numerator, same term in denominator. And each of the power should be what? 1. Whenever power is not mentioned, what's the meaning? 1. But you see the question. Here we have x power 15 and here we have x power 10. So it is not matching with the formula. That's the reason I did this problem. Now what we are going to do, listen. Since whatever is there in numerator, same term I want in denominator but with power 1. So what I am going to do, divide both numerator and denominator by x minus 1. See just carefully what's happening. Limit of, this question is taken here now, x power 15 minus 1 divided by x minus 1 divided by, again, x power 10 minus 1 divided by x minus 1 as x is tending to 1. Now you see, now this is exactly matching. Sir, power of a is n, power should be same. No problem. Since power of x is 15, I can write this one as what? 1 power 15. 1 power anything is always what? 1 only. And you can see here, that's what the basic power I took, 32 was there. Since I have got x power 5, I expressed 32 as 2 power 5. And it is 32 only. Next, come to this part. Power of x is 10. So I can write 1 power 10. Now see carefully. We are having this term matching with the formula and this also matching with the formula. I just completed algebra of limits. So it is f by g. So I have to apply the limit for both of it. So how we are going to write? Limit of x power 15 minus 1 power 15 whole divided by x minus 1 as x is tending to 1 whole divided by, again this limit for this, x power 10 minus 1 power 10 divided by x minus 1 limit as x tends to 1. But in our future class, we may not write like this. It's understood that this limit is applied to each and every term. Okay, since it's a beginning class, so I thought I'll go step by step. This step we can avoid. Now you see this particular part, this entire thing, if I compare with the formula here, in place of x means in place of this power n, we have what, 15. So for this part, for this entire numerator, for this entire thing, I can say n is equal to 15 and a is equal to 1. Minus and minus getting balanced, a is positive. Similarly, for this part, if we observe carefully, in place of this n, we have 10. So n is equal to 10 and a is equal to 1. So now what we are going to have, see carefully the value of this. This entire value is n into a power n minus 1. N is what, 15. A is what, 1. Whole power 15 minus 1. Whole divided by this entire value. Again substitute here. What, n? 10. Whole power 1 into, I mean 10 into 1 because n into a. Then whole power n minus 1. N is what, 10 minus 1. This entire thing is in numerator, means power it is. Now, very simple. 1 power anything is what? 1 itself. So, I am going to get the value to be, let I erase this side. This part that I erase. See this, finally, we are going to have, without any problem, this is going to cancel. 5 3s are 15, 5 2s are 10. So, answer will be 3 divided by 2 into, this is again 1 only, this also again 1 because 1 point is what, 1 only. So the final answer is 3 by 2. It's a real number, therefore the limit of this is 3 by 2. Always my output should be a real number only. Okay, I hope this is clear. Kindly make a note of this. It is continuing till here. Okay, only this part. Fine. Okay, dear students, having completed this problem, as I said, this problem also came in model question paper number 2. So I have just mentioned the question number. It is 27. So make sure you can make a note. It has been asked 2 times, one with the derivation as a sub problem, other in model question paper number 2, question number 27. On this, I have given an assignment. See, don't be stick with only one variable x. I can also use some other alphabet. So it is z. So apply the same logic, get the answer, and the answer for this you should get to be, why should I say, comment it. Okay. Now, one most important thing what I want to comment, while deriving this result, we have assumed that n should be a natural number. But this result is also true whenever n is a rational number. So who knows, for 1 marker they may ask, this is true for which all number? It is for all rational number as well. But in derivation, they have restricted in NCERT only to natural number, nothing but positive integer. Okay, you can make a note of this. So very importantly, this one. Okay. Okay, dear students, let us move on to next problem. These are not from the model papers, but as I said, I want to go for all the concept and the problem on limits and derivatives, as it is very important for second PUC and also for derivative, the upcoming topic. Okay, so now just see this again, limit x plus 1 whole power 5 minus 1 whole divided by x as x is tending to 0. Now this time is tending to 0. Fine. Wherever x is there, replace by 0 because x is tending to 0. Method of direct substitution. So wherever x is there, 0, then plus 1 whole power 5 minus 1 divided by 0. 1 power 5 is 1 minus 1, 0. I'll get 0 by 0. Nothing but indeterminate form. Indeterminate what form? Now, for this, we have just now derived the result. We know that limit of x power n minus a power n divided by x minus a as x tends to a is equal to n into a power n minus 1, where surely n is any rational number and a is positive. Okay, now let us try to use this and get the answer. I'll go in two methods. First, I'll exactly go with the whatever the expression is there here. We have only one term, but we have two terms here. So let us try to make this entire as one term. So I am going to go for solution, substitution. Put x plus 1 is equal to y, some variable y. Okay. Now, why am I taking this? As we can see here, it is one single term. So same thing. Now, when I'm substituting, limit will also change. See carefully. Here in the question they have given x is tending to 0. I want to know where x plus 1 is tending. So since I have got only x here, but I want x plus 1 here. So what is missing? See, compare both. X is same. 1 is missing. Add 1. When I add 1, I will get x plus 1 is tending to 0 plus 1. What is 0 plus 1? 1 itself. So x plus 1 is tending to 1. So my given question will become whatever we have here, limit of, let us write once again for better clarity. See carefully. Now it will be x plus 1 is y. So in place of x plus 1, it is y power 5 minus 1 divided by, again in place of x, since I've got x solve for x, if I transpose here, I will get x is equal to y minus 1. Right? So wherever x is there, y minus 1. And as x is tending to 0, my new, and what is x plus 1 here? Y. So y is tending to 1. So as x is tending to 0, y is tending to 1. Y is tending to 1. Now see, this particular expression with this, both are okay now. Both are now same. Single term, yes. Now power is n, so same power. Here power is 5, so I will let power to be what? 5. Okay, I just gave a tick, I'm erasing that. Now compare. See, we want only n and a. So a, in place of a, what do we have? 1. In place of n, what do we have? 5. So what is the answer? N into n is 5. Then a, what is a? 1. Whole power n minus 1. 5 minus 1 is what? 4. So I'll get 5 times of 1 power 4 is 1. 5 into 1 is 5, which is a real number. And this is the limit value. Whatever the answer we're getting, a real number for all the limit question, those are what? Limit value. I hope this is clear. There is one more way of solving. See the alternate method for the same problem. Let I copy the question. Minus divided by x as x is tending to 0. Correct now? So when you compare with the formula which is present here, this formula, okay, in place of making single term, no, I've just made a single term here, substitution I did, correct? Here, single term I made. But in place of that, Okay, dear students, let us try to solve the same problem in one more method. First, observe this. Here, what I tried to do I just made this term single term going with this. Now, we'll not do as such. We'll try to make whatever is there in numerator same in denominator. See carefully that. X, A, correct? No, see here. I will write in next line. I have to make numerator denominator same, but without substitution. Very simple. I have just copied the question. Now, what do we have here? Plus 1 and minus 1. So, I will add 1, subtract 1. Plus 1, minus 1 will get cancelled. I will get x is same here. Yes. And here limit also. I will add both the side 1. Nothing but as x is tending to 0, x plus 1 is tending to 1. Now, see carefully. Exactly matching now. Whatever term here, same in denominator and same term. Yeah. X plus 1, x plus 1. Here power 5 I can give, always for 1 I can raise whichever power I want. Now since I have got 5, same power. Now what's the answer? N into a power n minus 1. In place of a, 1. And in place of n, 5. So substitute here, n into a power n minus 1. So n into n is 5. A is 1, whole power n minus 1, 5 minus 1, which is 4. So I will get 5 into 1 power 4 is 1. 5 into 1 is 5, which is a real number. That's what we got here also. Okay. So I would like you to take this as an assignment and get the solution. Kindly make a note of it. Okay. Yeah. Dear students, let us move on to one last problem before we take limits concept on trigonometric functions. This is an example problem 2, page number 231 of your NCERT, and that's the problem. Limit as x tends to 2, x square minus 4 whole divided by x cube minus 4x square plus 4x I have to evaluate. Now, if you apply the limit, just see what you are going to get. Wherever x is there, 2, nothing but method of direct substitution. So what we are going to get? 2 square minus 2, sorry 4 no, minus 4 divided by 2 cube minus 4 into 2 square plus 4 into 2. What is 2 square? 4 minus 4 divided by 2 cube is 8 minus 2 square is 4. 4 4s are 16 with minus sign. Then 4 2s are 8. If you see, this is 0 by 0, nothing but indeterminate form. You know that, okay? I just wrote IF, you know that, okay? Now, method of factorization will think. So, see carefully. I cannot think of applying the other formula which we just learned because degree 2, degree 3 is also there. So, first let us try to factorize, okay? So, let us do it here. Can't write x square minus 4 as what? X square minus 2 square. Now it resembles the formula a square minus b square. What is a square minus b square? A plus b into a minus b. So in place of a, x, in place of b, 2. So we are going to have x plus 2 into x minus 2. So the numerator becomes x plus 2 into x minus 2 divided by. Now coming to denominator, let us take it here. The denominator is x cube, okay, minus 4x square plus 4x. What is common in this? X is common. So remaining is what? X square minus 4x plus 4. And now it's a quadratic. I can factorize. 1 into 4 is 4. So x square. So 4 I can write now. 2 2s are 4. So minus 2 is minus 4. So we can factorize. So minus 2x here, minus 2x plus 4. Then x square of, here common is x. So I'll get x minus 2. Here common is minus 2. So minus plus x here because minus 2 minus into plus will be minus. So since 2 is out, 4 by 2 will be 2. Actually, we are dividing. Whether you divide the sign or multiply, both will give same. Nothing to worry. Now, x minus 2 is common. So x square as it is into x minus 2. Then remaining is what? X minus 2. Let us write it here. Denominator is x square into x minus 2 into x minus 2. Sum of the term will get cancelled. See carefully. X minus 2 and x minus 2 got cancelled. Now apply the limit. Before applying the limit, let us write down the remaining term. Purposefully, I have taken this problem to highlight one important point. See carefully. As soon I applied the method of factorization, the term which is giving 0 by 0 got removed, got cancelled. But we cannot. The motive of this problem is it something like every problem will have a limit? Nothing but limit exists. For that, I have taken this problem to comment. Need not be. See this carefully. Now, when you apply the limit, x is tending to 2. So 2 plus 2 divided by 2 square into 2 minus 2. 2 plus 2 is 4. 2 square is 4. 2 minus 2, 0. 4 by 4 gone. But 1 by 0. What is 1 by 0? Undefined. So, limit does not exist. Limit does not exist. You are not going to say question is wrong. Limit does not exist. So, every problem need not have limit. Limit may also be like this, that it is not existing. Okay. So, kindly make a note. Okay. Dear students, having understood all the limit concept on rational functions, or I can say the algebraic terms, now time has come to move on for trigonometric functions. Okay, for that we are going to understand two important theorems, and then we'll go with the derivations. So, as per NCERT, there is a numbering for theorem. This theorem is 3. You may be thinking, what about theorem number 1? Algebra of limits we learned, that is theorem number 1. Okay. Now, what this theorem says is, let us have a diagram for this. See carefully. Okay. Okay. Let us try to understand this theorem. Theorem proof is not required, only the result. And let us understand with the help of a diagram. Let us suppose I have got a function whose graph is this, and this function is y is equal to f of x. We have one more function whose graph is this, and the equation of this graph is y equal to g of x. Okay. Now see the behavior of this function. Can you just see by seeing which graph is having more value and which is having less? Nothing but who is larger? Sir, you are not given any numbers here. Numbers not at all required, my dear students. Just one basic logic. If you have, for example, take a number itself. If you have 1 here, what will this number? Don't say 2. Say more than 1. Say more than 1. Because who knows, this can be 3 also. This can be 1.8 also. So, as and how you just move up, the value are increasing. So, similarly, see this blue graph which is y equal to g of x, and this black graph, that is black color graph, y equal to f of x. Both are function. And since this black color graph is below compared to blue color, it's very clear that f of x is lesser than or equal to g of x. But before we go ahead this, I hope you are clear. Before we go ahead this, first what are the primary condition? Let origin here. Both f be a function from a to b. I am purposefully incorporating function concept here. In text they have just said let f and g be the function having the same domain. But I thought let us have like this so that again you're recalling. First set is domain, second set is codomain, and G is also a function from A to C. So one thing is very clear: domain of both the functions should be same. Codomain may be different, no problem, but domain should be same. And when it is happening and is defined, both the functions are defined, and f of x is less or equal to g of x for all x belonging to the domain. Domain is same for both. Don't forget this we call domain. When f is a function from A to B, first set is domain and the second set is what? Codomain. Here also you have got domain and here codomain. So you can see I have taken both same. So domain should be same. And if this condition happens, then if this happens, then the limit of f of x will be less or equal to limit of g of x as x is tending to a. So what is the summary of this? The summary of this is, if I have two functions f and g such that there is an inequality satisfied by them for each and every x in the given same domain, then even if I apply the limit also, I am going to have same scenario. You can see here, if I take a limit and that point is here, a is here. So when I go from here or here, even for this also, ultimately they are coming for the same value. So equality. But you see here, if you take a here, now you see this limit value is somewhere here, and for this limit value somewhere here. So let us suppose this limit value is L1 and this is L2. So very clearly it is from here that L1 is less than L2. I hope this logic is clear. Okay. So it can be less or equal to, it can be both. Okay. Now one more theorem which is the base for our derivation of 5 marks. Theorem number 4. What it says. Now we have 3 functions and having this 3 function, let I take one more color for a while. Okay, now we are going to have 3 graphs. See carefully the first graph and this equation. Let us suppose y is equal to f of x. Okay, and our functions. Next graph. Yeah, I'll take in black color, and this graph is this. Okay, and this graph is y is equal to g of x. One more graph. I thought y to go down, can go anywhere, no problem. One more graph. In that color we'll take. And this graph is y equal to h of x. So we have got 3 graphs and all are functions, and they are intersecting here. One point is there, that point will take us A. So from the graph, f is a function from A to B. Let this happen, origin here. Let A be the function from A to B, G be the function from A to C, and H be a function from A to D. Again you see domain of all the 3 functions should be same. That's the primary condition. Then if this happens, if what next? See the graph. You can see f of x is below g of x, g of x is below f of x. So I can say that f of x is less or equal to g of x less or equal to what? H of x. This is happening for all x in the domain. If this happens, and not only that, the limit of this f of x and g of x, both the limits should exist. So let us suppose the limit of this is some L. Also, limit of h of x is also L. That's what you can see from the graph. You can see here both are up to the same point. Correct? No. When I go from right of A or left of A, it is approaching the same value, and that value is somewhere here. That is L. And we are talking only about this red color one and the blue color one. We don't have any information about limit value about this. When I'm writing L, nothing but the limit exists. Then what we are saying, since this g of x is between f of x and h of x, and both f of x and h of x, I repeat, g of x is between f of x and h of x, and both are having the limit value. Therefore, when I take the limit value, I want to find the limit value of g of x at the same point A. This also will have L only. You can see here. All, let it be red color, black color, or blue. Similarly, red, black, blue, all are converging to the same. This we call sandwich theorem. And what is happening here? Sandwich, no? Sandwich, pizza, sandwich, all that. So, in between the two, it is present. That's what, no? In between this h of x red color and f of x blue color, g of x, the black color graph, is sandwich. So, whatever the behavior h and f is happening, the limit value same we are going to have, provided this condition is obeyed. Similarly, here I would like to only comment, when I'm writing this, it means limit of f of x and limit of g of x as x tends to a exist. Let us write that also. And limit of f of x as x tends to a, and limit of g of x as x tends to a, what? Exist. Okay. Obviously, when we write limit, no, it should exist. So this is the theorem, and again L is what? A real number. All of this are real number L. Okay. So with this, we are ready for our 5-marker derivation. Kindly make a note. Dear students, having completed the 2 basic theorem on limits of trigonometric function, now time has come to move to the very important 5-marker short question in all the papers from 2014 till date. This question has come, same like cos of x plus y, and this question has come both in model question paper 2 as well as 3. But coming to 3, there is one variation that I'll discuss after I complete the derivation. Now the question says, prove geometrically that limit sin x by x as x tends to 0 is 1. And the angle whichever is there, x here, it is measured in radian. Don't forget, we have got, with respect to trigonometry, 2 ways of measuring the angle in the syllabus of PUC. One is degree, other is radian. So we are saying it is in terms of radian, and this question is from model question paper number 2. So now, let us go for this proof. See here, we have, and actually this is in the textbook taken as theorem number 5, okay? But before that, see carefully, I have to prove this. And if at all you want to go directly, see carefully. If at all I want to evaluate limit of sin x by x as x tends to 0, wherever x is there, d plus by 0, nothing but x is tending to 0. So what we will get, see carefully, method of substitution, sin 0 divided by 0. Sin 0 is 0, 0 by 0. We are getting indeterminate form. Now you cannot think of factorization method. Now you can apply the formula which we have taught. Why not factorization method? You have only one term. With one term, we can't factorize anything. If you should have more than one term, better more than 2 terms to factorize. So now comes this derivation. Now because of this reason itself, since we are not able to evaluate and we are getting indeterminate form, therefore we are going for this derivation. You should know the reason. Now, since we are not able to evaluate directly, we shall first prove one inequality, that is cos x is less than sine x by x less than 1, where this angle is between 0 less than mod x less than pi by 2. Be careful, mod is there. It means both positive x and minus x is there. If you just see carefully, if you break this, let us try to understand in detail. If we try to remove the mod, or the both cases, if I take, what the both cases, see carefully. If x is positive, and one more case is when x is negative. If x is positive, this will be 0 is less than x less than pi by 2. And if x is negative, mod x will be minus x. No. So I'll get for this scenario 0 less than minus x less than pi by 2. Multiply throughout by negative. Don't forget, if you multiply by negative, inequality will change. For example, 3 is less than 5. If you multiply by negative 1, multiply by minus 1, negative, it's a negative number. So just see, 3 into minus 1 and 5 into minus 1. 3 into minus 1 is minus 3, 5 into minus 1 is minus 5, and now minus 3 will be larger than minus 5. So whenever you multiply or divide by negative number, inequality will change. So if I multiply by negative number here, that is multiply by minus 1, which is negative, we are going to have 0 into minus 1 less than minus 1 into minus x less than minus 1 into pi by 2. Simplify, 0 into minus 1 is 0. Then the inequality will change, I said. So this will become what? Greater than, and this also will become what? Greater than. So minus to minus will be plus. Then here minus pi by 2. Or this is same as 3 is more than 2 more than 1 is same as 1 is less than 2 less than 3. So this is also same as minus pi by 2 less than x less than 0. What I'm trying to say here, if I write from rightmost to leftmost, the inequality will get reversed. So the rightmost to leftmost when I write, inequality get reversed. So this mod is covering two regions. This is first quadrant and this is what? Fourth quadrant. I repeat, let us have this all detailedly understand that when I plot here, see carefully, 0 to pi by 2 is first quadrant. The angle is going from here to here, angle x. Whereas minus pi by 2 to 0, nothing but from here to here, it's a clockwise, and it is minus x. So it is covering both first and fourth quadrant. Okay. Now let us prove this. So this has been a bit extra part which I have just explained, so that we'll have very good clarity. Now let us go for the derivation. Now here I have to prove this, but since I've got mod, so I have to also bother about negative x. See carefully the same result if I consider negative x. So if x is negative, nothing but if I take minus x, so see this carefully, for mod x minus x, if I take here for negative x, see carefully, wherever x is there, replace by, I can just say here, for negative x, wherever x is there, replace by minus x in this equation number, inequality number 1. So cos of minus x, sin of minus x by this, and 1. Since there is no x, 1 remains 1. What is cos of minus theta from trigonometry? Kindly refer the video of trigonometric function. We have discussed all this. So what is cos of minus theta plus cos theta? What is sine of minus theta minus sine theta? So from here, cos of minus x is plus cos x, and sine of minus x is minus sine x divided by minus x less than 1. So negative will get cancelled. So we have cos x less than sine x divided by x less than 1. What I'm trying to say, if x is negative, and since x is negative, for this we are talking about, for this condition, when I'm replacing x by minus x in this, I got the same back. You can see whatever is there here, same we got here. So what's the meaning? Meaning is no need to bother or no need to derive separately for negative x. We can only concentrate on positive x, nothing but first quadrant, no need to go for fourth quadrant. So now let us try to proceed. So now we are going to prove what? Cos x is less than sin x by x less than 1, and here the region is between 0 less than x less than pi by 2. Now here I have removed the mod. As you can see, even if I take negative x, I'll get the same result. I hope this point is clear. Now let us proceed. The right side, is it recording now? Yes. Okay. Always no doubt will be there. Now see carefully how we are going to go ahead. So we want to prove this, and we are going to apply sandwich theorem. Mean to say, we'll try to find the limit of this, and this is in between them. So by using sandwich theorem, we can get the result. But I have to come to this. Now how to go for that? We have considered a unit circle with center O and the radius. Since I said unit circle, radius is 1 unit. Now let us first try to describe the figure. So let us consider a unit circle with center at O. Okay, and you see carefully, I have just made sure OA and AB, they are perpendicular. Reason, this is radius. Always from school days we know angle between the radius and the tangents are what? 90 degree. Correct? No? 90 degree. So let us join. First let us join OA. Okay, and draw what? OA perpendicular to AB. Now let us go to the diagram one by one. So one thing that I comment, this thing in blue color you can ignore for examination point of view. Only this part let you take, and whatever I am deriving it. Okay, only this blue part you can ignore. Just I wanted you to understand the what is actually happening there. Now see carefully. From the diagram, from the figure, can you see one triangle? O, A, C. Okay, so from figure, what is happening? Area of triangle OAC. Area of triangle what? OAC. Is it not that is less than area of the sector? Can you see a red color here? O, then A, then you see here C. So this is an extra area compared to triangle. What is a sector? First let us recall from school days. What is a sector? It is a area bounded by two radii and an arc. This we call sector. Sector. OAB. It is an area bounded by two radii and an arc. And let us suppose the angle is theta. Then I want to find the area of this sector. The area of this sector is given by, yes, school days. It is actually pi square of the radius into theta divided by 360 degree. But since we are measuring the angle in terms of radian, what is pi radian? 180 degree. So since this is 180 degree, then r square theta divided by 360 degree. 180 degree, 1's are 180 degree, 2's are. So I'll get half square of the radius into theta. That will be the area of the sector. So majority of the students will remember this. Now the formula is reduced to half r square theta. So I think better you make a note till here. Let I erase it, and then let us start from here only. Okay, kindly make a note of this. Okay, dear students, I have written some of the things. We have to prove this and area of sector concept. Okay, fine. Now let us proceed. See carefully. See this diagram. What we have got? Area of circle. Area of triangle. Area of triangle. Which triangle? O A C. This triangle. Correct now? So area of triangle OAC, is it not less than area of the sector O A, and see this one C, and you can see one extra area is here. So because of this area, this region, I can say area of triangle OAC is less than area of sector what? OAC. Again that is less than what? Big triangle OAB. This bigger triangle, you can see this much of area is left out. So area of triangle OAB. Now let us apply the formula. What is area of a triangle formula? It is half into base. Base is OA. For this triangle I am talking about OAC. Base is OA, height is CD. So half into base is OA, height is CD, less than area of sector. Formula is what? Half square of the radius into the angle which is made here. Okay. So half square of the radius. Radius is OA. So square of that. Then angle is X. Less than area of triangle OAB. So half of base is OA. Height is AB. So half of base is OA. Height is AB. Now we don't have two inequality, we have three. Okay, so throughout we have to perform the operation. Don't think something like, no, I've got only this two, so half will get cancelled here, something like, no, throughout. If I've got one more inequality in case, throughout it should be. Now as we know that just now we discussed that if you multiply by negative, inequality will change, but for positive it will not change. Okay, so let us go with that, and I just explained that also. If I have got 3 less than 5, multiply by, for example, positive quantity 2, which is positive. So what will happen? 2 into 3, 5 into 2. I just given a box here. We don't know what's the result still. 2 3s are 6, 5 2s are 10. Again 6 is less than 10. So whenever you multiply a positive term, inequality will not change. So whether you multiply or divide by a positive term, inequality will not change. So here throughout I can just say multiply by 2 and divide by OA. OA is what? Radius, nothing but length. Length cannot be negative. So we are going to divide by OA. So after this, okay, what we are getting, see carefully, remaining term. The remaining terms are CD less than OA, X less than AB. This is our first inequality. We can also see that CD is there, OA, X is there, and AB is there. Correct? Yeah? Now try to understand before I go ahead. Okay, CD, OA and AB. We want this one to be there. Nothing but trigonometry I want. So one by one, see CD. Where is CD? CD is here. So let us take this right angle triangle CDO. Let us write that. In right angle triangle COD. Now let us take this right angle triangle. The angle is X here. So it is CDO. Now which trigonometric function to take? See, I don't want the length. As you can see, I want only trigonometric function. So CD, where is CD? It's here. That is opposite to X. And as you can see, this triangle circle OA and OC both are radius of same circle, so they are equal. So I will take better this because I can have throughout what? OA. So this is hypotenuse. So which is the trigonometric function which will have both opposite and hypotenuse? Sin X. So similarly cosecant also, but sin X will prefer always primary trigonometric function. So opposite is CD, hypotenuse is OC. But since, okay, first I cross multiply. So what is CD? It is OC into sine X. But since OC same as OA, radius of the same circle, so I can write this one as CD is equal to OA times of sine X. This is our second equation. Now let us move on. OA, you can see OA here coming back. For CD, we have got this value, OA as it is. So there's no problem with this. Problem is here, AB. AB is here, the big triangle. So let us take the big triangle in right angle triangle OAB. So in right angle triangle OAB, let us construct that right angle triangle here. Here is the angle X, here it is O, then A, then B. Now I don't want AB, so AB, it is opposite to the angle X, and OA we want to maintain throughout because radius of the circle. So it is this, nothing but adjacent, which is the trigonometric function which goes with opposite and adjacent. It is tan. So tan X is equal to, opposite is AB, adjacent is OA. So cross multiply, AB is equal to OA into tan X. This is third equation. Now I can substitute 2 and 3 back in 1. So put equation number 2 and 3 back in 1. So CD, what is CD? OA sin X. OA sin X. Let us highlight OA separately. Next, less than OA X, OA into X, less than AB. What is AB? OA into tan X. Now throughout, you can see that is we took everywhere OA. Now you can see OA can be cancelled, or we can divide throughout by OA. OA is a length, inequality will not change because it's a positive quantity. So divide throughout by OA. When I divide throughout by OA, OA gone. Remaining is what? Sin X is less than X. Less than tan X. Now see carefully what we wanted to prove. We intend to prove this. See the middle term, sin X by X I want. Here I have got only X. So I want sin X and X combination. So what I will do, I will divide by sin X. When I am dividing by sin X, first we have to make sure whether sin X is positive or negative. Don't forget the range of sin X is closed interval -1 to +1. But since we are only going for open interval 0 to pi by 2, nothing but first quadrant. In 0 to pi by 2 first quadrant, all the 6 trigonometric functions are positive. So sin X is also positive. Inequality will not change. So sin X divided by sin X less than X by sin X, and tan I can write as sin X by cos X. This tan I can write like this, and don't forget we are dividing by sin X. I repeat, for tan X we got sin X by cos X, and we are dividing by sin X. Now see, some of the terms are getting cancelled. Which are those terms? Sin X by X, sin X by sin X gone. Here also sin X, and here sin X gone. What is the remaining term? The remaining term is 1 is less than X by sin X less than 1 by cos X. Okay. Now let I erase this side. Let us not erase what we intend to prove it. See carefully, we are ultimately coming to an end. So after this, this is the last part. So see carefully. We want to prove this, we have got this. See carefully the middle term here. We wanted sin X by X, but we have got X by sin X. So this and this both are reciprocal of each other. This term and this term. So what I will do, take reciprocal. Now when we take reciprocal, see carefully. I am not using the word on both sides. We have three inequalities. So only take reciprocal word is sufficient. Now see one important basic logic. Is 1 less than 2 less than 3? Yeah, obviously. If I take reciprocal, reciprocal of, take reciprocal. If I take reciprocal, reciprocal of 1 is 1 itself, 2 will be 1 by 2, 3 will be 1 by 3, and 1 is more than half, that is 0.5. And half is more than 1 by 3 because this is 0.3. So 1 is more than half and this is more than this. Okay, 0.333 it will be. So when you take reciprocal, inequality will reverse. So when taking reciprocal, 1, yeah, 1 itself. This less than will change to greater than, and this x by sin x will change to sin x by x. Then again greater than, 1 by cos will be cos x. Again, see carefully. Is it not? Very basic elementary thing I am saying. If 3 is more than 2 more than 1, which is true. If I change the order, 3 more than 2 more than 1. If I first write first 1, then 2, then 3, inequality will completely what? Reverse. Correct? So similarly here also, if I write the rightmost term, cos x will be less than sin x by x will be less than 1. That's what we needed to prove. Now come back what we want. We have to take limit as x tends to 0. So take limit as x tends to 0. How we came to know? Because of the question. When I take as x tends to 0 the limit, we are going to have limit cos x as x tends to 0 less than limit sin x by x as x tends to 0 less than limit 1 as x tends to 0. Now sandwich theorem is coming into picture. What was that theorem? If f is less than g, g is less than h, and limit of the leftmost and the rightmost function exist and they are equal, then even the term in between them, sandwich between them, also have the same limiting value. Now just see here, cos 0, apply the limit here, cos wherever x is there, 0, cos 0, but here I am not going to apply the limit. As you know, we will get 0 by 0 form, and wherever x is there, x is tending to 0, there is no x, 1 remain 1 only. What is cos 0? 1 less than limit sin x by x, x is tending to 0 less than 1. See carefully what is happening here. Let it be the limit value of the function lesser than sin x by x and more than sin x by x. Both the function is having same limiting value 1 and 1. Therefore, by sandwich theorem, we can say that limit of sin x by x as x tends to 0 is also 1. By what's the reason here? By sandwich theorem. We are going to surely mention the reason how it is that it became 1. So with this our result is done. Order of copying will be after, because this circle was there before erasing, so this is the first part, completely copying, then with this all, then this will be the second part of copying, then this will be the third part of copying, and ultimately from here it is the fourth part. Okay, it is a bit lengthy and I've tried to give each and every reason for the change of inequality, etc. And this has come in model question paper number 2 without any sub problem. Coming to model question paper number 3, what they have did, in place of x, no, they are given theta. Question is like this, prove geometric everything, but they are given limit sin theta by theta as theta tending to 0 is equal to 1. Now you have two way out. One, throughout the derivation, you have to use theta if this is the question. You cannot use x because in question they are given theta. You cannot give your own variable. Sir, when I'm writing, surely no, since we have a practice of writing even textbook also, we have x, we may practice in terms of x, and when you want to write here, we will be in trouble that in some way, in some step, we might write because no practiced in terms of x, we may write somewhere x, even though the question is this. For that, the best remedy will be when you start the derivation, you can just mention like this. What? Let us assume. What you can write is, first I hope you have taken, okay. Now see what we can write now. Before you start, if this is the question, let theta is equal to x, specify this. And then solve the problem for x. No problem. Okay. So, I hope the things are clear. Kindly make a note of this. Dear students, having completed the 5-marker derivation, now let us take some problem on this. As I said, in none of the model paper, there have been any sub-problem on the derivation. But let us have, as I said, no, this chapter as we need for derivatives, the next topic, and for second PUC, 5 chapters. This is going to be the basic. So I thought why not to cover this. Okay, and it's very simple also. You just see. Okay, now for all this, again I am applying method of substitution only. Evaluate. Example number 4. Limit tan x by x as x tends to 0. When I apply the limit, wherever x is there, replace by 0. Nothing but x is tending to 0. Tan 0 divided by 0. What is tan 0? 0 itself. And coming to tan angle table in chapter trigonometric function, you can just see the angle values there. Now, whenever we stuck in trigonometry, whenever we have got 0 by 0 form, now this result which we have just completed will be memorized by you as a standard result, that is limit sin x by x as x tends to 0 is 1, where x is measured in radians. So here we have tan, but I want sin, only then I can apply. So we can rewrite the question as tan is same as sin x divided by cos x, and this x as it is. Now I can apply the limit by algebra of limit for each one of this. So here, as I said previously also, I want to apply limit for this 2 term and this separate. Let us not show that step, just this entire, when I apply the limit by using this, it will be 1 divided by cos x is tending to 0. So this place of this x, it will be 0. What is cos 0? 1. So 1 by 1 is 1. So the value of this limit is what? 1. This is one of the standard limit to be remembered. Next, come here. Again, see this. First, always apply the limit by method of direct substitution. If you get 0 by 0 form, only then you have to think about this result whenever trigonometry is there. See, when I apply the limit, x is tending to 0, a into 0 is 0. Sin of a into 0, it is like step by step, divided by b into 0. A into 0 is 0, sin 0 we will get, divided by b into 0 is 0. So I'll get sin 0 is what? 0 itself. 0 by 0 form, indeterminate form. So now to apply this, see carefully. Whatever angle is there, same angle is here. What's the angle of, see, whatever angle sin is having, same angle we have in denominator. Angle of sin is ax. So, sin limit of ax divided by x, and the b which is there in denominator, I'll take it out because the limit is only for x. Now, see the angle of sin, it is ax. Whatever angle we have got, same angle we want in denominator. So what we can do, since ax is the angle for sin, only x is there, we are going to multiply and divide by a. Then we are going to get 1 by b as it is. Okay. So limit of sin ax divided by ax. We are dividing by a, and when I said multiply, I multiply outside the limit, because anyway x is tending to 0, not a. Now see carefully, for this entire, this goes with this theorem result. So 1 into a is a divided by b. This entire value is 1. So answer is a by b, which is a real number, because in the question they have specified a and b are what? Non-zero. Okay, this is clear. Fine, let us move on to this problem. Again, when I apply the limit for this, wherever x is there, replaced by 0, a into 0, sine of a into 0 divided by sine of b into 0. Okay, what is a into 0? 0, so sine 0. B into 0 is 0, so sine 0. So what is sine 0? 0. So 0 by 0 form, indeterminate. To apply this, whatever angle is the same angle should be in denominator. Here the angle is ax. So what we can do? Multiply and divide by. Multiply and divide by. Okay, let us go one by one. I am first talking about numerator. NR stands for numerator. Coming to numerator, angle is ax. Whatever the angle is the same angle I should have in denominator. So multiply numerator, multiply and divide by what? Ax. Coming to denominator, multiply and divide by bx. Why bx? Angle is bx here. I have to match with this. So now we are going to have limit of sine ax. So I am dividing by ax and I am multiplying by ax, whole divided by sine bx. And again here we are dividing by bx and multiplying by bx, as x is tending to 0. Now see carefully, this x and x will get cancelled. Now for this and for this we can think of applying the limit, this limit. Now this part exactly obeys with this. So this, when I apply the limit for this, I will get this entire value to be what? 1. Again this entire value to be what? 1. Then a by b. A by b into 1 will be a by b, which is again a real number. And in the question they have specified a and b are not equal to 0. So there are some non-zero terms. On this will be assignment. You can see in place of a and b we have 4 and 2. Now let us take this very important result. Okay, limit of 1 minus cos x by x square as x tends to 0. Again apply the limit. Wherever x is replaced by 0, what I will get? 1 minus cos 0 divided by 0 square. What is cos 0? 1. 0 square is 0. So I'll get 0 by 0, nothing but indeterminate form. Now we want sine, only then we can apply this formula. Tan was to be converted to sine and cos. Here both were sine, no problem, but angle were not matching. We made sure that angle should match. Now how to go about this? We have in trigonometric one formula. What? 1 minus cos x is 2 times of sine square x by 2. So we are going to have limit 1 minus cos is what? 2 times of sine square, whatever angle is there, half of that, x square by 2 divided by x square, divided by x square. Now we want to apply, wait, I think the question is only with x, yeah. Now let us proceed. Okay, now x is tending to 0. Apply the limit again. Wherever x is there, what? 0. 0 by 2 is 0. So 2 times of sine 0 is 0 divided by 0, I'll get 0 by 0 form. Okay, now I'll apply this formula. To apply this formula, power of sine is 1, here also 1. So 2 out, can't I rewrite sine square as sine x by 2 into sine x by 2, or in place of into give a bracket to avoid confusion. Then this divide by x, any one term I should divide it, and this 2 which is there in numerator I can bring it down, it is here. Why sir you did this? So that we can match the angle. Here angle is x by 2, so x by 2. Okay, so I'll take this 2 out, I've taken down. Now apply the limit. When we apply the limit, this entire value with the limit is what? 1 into. Now wherever x is there, replace by 0. For this I will get sine of 0 by 2. What is 0 by 2? 0. So 1 into sine 0. But what is sine 0? 0. 0 times 1 is what? 0. 0 is a real number. That is our limiting value. So with this entire concept and all the problems coming to the concept is done. I would like to give you previous year question paper problem assignment on the same. First, kindly make a note. Okay, dear students, from annual board exam, that is 2024, these are the assignment problems from only limits. Okay, so with this we come to an end for part 1 on limits and derivatives. In this part 1 completely we have finished limits. Coming to part 2, we are going to take derivatives. Okay, so make sure study well, do the assignment. Make sure simultaneously after I finish explaining, take a pause, put a pause for the video, copy down simultaneously, write and learn. And after video seeing is over, watching the video is over, with full dedication, make sure practice. Okay, so make sure study well. All the very best. Do well. God bless you all. And make sure study well. Do share, like and subscribe to my YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you.